All right, folks, let's take a look at example 6. We're going to decompose this fraction. I can see I've got a linear factor here and I've got a quadratic factor, but I would need to determine if I could reduce this or not, right? Can I break x squared plus x plus 2 into two linear factors, right? If this can break into two linear factors, like just for example, like x plus 1, x plus 2, then I would use the techniques of only having non-repeated linear factors. But if I can't break this down, if this is an irreducible quadratic factor, I need to use that technique. So in general, we think, are there two numbers that multiply to positive 2 but add up to positive 1? And we can just do a quick guess and check here. But to give you an idea, right, if I want to try and break this down, and I'll make these factors a little bit more distinct. The only things that multiply to x squared are x and x. The only integers that multiply to 2 are 2 and 1. Right? And if I look at outer and inner in this case, this is 2x here, this is x here. If I want to get 2x and x to be positive x, right, I want that middle term, then this would have to be positive, this would be negative, right? So I would go ahead and I put the plus here and the minus here. And outer and inner would give me x, but the problem is that positive 2 times negative 1 is not positive 2. So this does not actually break down. This is an irreducible quadratic factor. All right, and another way you could kind of suss that out is if you look at the discriminant, if you were going to run the quadratic formula, b squared minus 4ac, in this case that would be 1 squared minus 4 times 1 times 2, you would ultimately get negative 7. And when your discriminant is negative, you don't have any real zeros. They're imaginary, which means it's irreducible, right? I can't break it down. So I'm going to erase all of this work because ultimately I want to start, this is going to take a good chunk of the page, but ultimately I'm learning I have, and I'll just write here, I have a linear factor, and then I have an irreducible quadratic factor. And to be clear, you don't have to write this each time. I just want you to see, or I want to write out the factoring that I'm going to move forward with. All right, once you start to see the pattern, you can just start building your fractions and go with it. And in terms of my fractions, let me go ahead and erase, right? I'm looking at this saying, I'm gonna do a constant over my linear factor. Oops, that should say 3. And then a linear numerator over my irreducible quadratic factor. All right, so there's the equation I'm setting up. And like always, I have this equation with fractions. I'd like to get rid of the fractions. So what I'm going to do is I'm going to take that LCD of x plus 3, x squared plus x plus 2, and I'm going to multiply that to every single term, right? Multiply to the left side of the equation, multiply to the right side of the equation, which means distribute it to both terms, and watch for things to cancel. So let me go ahead and start to write that out. So we'll have x plus 3, x squared plus x plus 2 times the left side of my equation. And then I have to write all of that to both terms in the right side of my equation. And I will say, the more experience you have with this, you might be able to skip this step. I don't know that I'd recommend it in the beginning, but maybe you're like, you start to see, okay, if I've got this LCD, I know it's going to knock out all of this denominator. It's going to knock out the x plus 3 here and the x squared plus x plus 2 here. So I can go ahead and just kind of hop to the next step. And if you can't, then write it out, right? I mean, it's a little bit annoying to write it out, but it doesn't take a ton of time. So all of my denominators cancel by design, and then I'm going to see what I'm left with. So I'm looking at 8x squared plus 12x minus 20 equaling a times x squared plus x plus 2. And then we have bx plus c times x plus 3, right? So I'll put both of those binomials in parentheses. There we go. So now we have a couple of options. All right, we can FOIL distribute all of this out, line up quadratic terms to quadratic terms, linear to linear, constants to constants, and set up a 3x3 system of equations. That is definitely one technique. Or you can plug in certain values of x and solve for a, b, and c. Up to you. I'm going to go ahead and do it both ways. And I'm going to do what I think is probably the longer way first. So if you want to fast forward to the shorter version, you're more than welcome to. But if I want to set up a system of equations, I need to FOIL all of this. So let's go with 8x squared, FOIL and distribute. 8x squared plus 12x minus 20. What do we have? ax squared, ax, 2a. Okay, so first, outer, inner, last. And then I'm going to start to line up terms. So I've got x squared, x squared, x squared. So I'm looking at 8 equaling a plus b. Okay? Let me do linear. 12x, we got ax, what else? We have 3b and a c. So I actually got all three letters in there. So 12 is going to be equal to a plus 3b plus c. Okay? Let's do constants, negative 20, I think I got a 2a and a 3c. All right, and then I've covered all of my terms. So negative 20 is equal to 2a plus 3c. Okay, so I can do this. Now again, you can solve with substitution or elimination, but what I'm gonna do is I'm gonna solve this top equation. I'm gonna solve it for b. I'm gonna write b in terms of a. And then this bottom equation, which will introduce fractions, I'm going to write c in terms of a. And then I'm going to substitute the b expression and the c expression into this second equation. So if I solve this top equation for b, I subtract the a over, I will get b equaling 8 minus a. Right? If I solve this equation for c, I'm going to move the 2a over, right? And then I'm going to divide everything by 3. So let me scooch this up just a wee bit so we can see a little bit more. Okay, so what I'm trying to say is here, I'm going to move the 3c over, so I will have 2a equaling negative 3c minus 20, right? And then if I want to solve this equation for a, I'm going to divide everything by 2. So that's what I'm going to write up here in just a moment, and I'm going to divide that 2 into both terms. So if I look at this, a should be equal... Oh, actually, JK, I just realized I did this in the wrong way. I want to solve this for C. Let me back this up. Let me back it up. I'm going to make the little noise as if I'm backing up. No, I'm not going to make the noise. Okay, I want to solve this for C because I want both letters in terms of A so I can substitute it into that second equation. So I'm going to go ahead and solve for C. I'm going to move the A over. So I'm going to have negative 2A minus 20 equaling 3C. Then I'm going to divide both terms by 3. Okay. Because what happens at this point, and I do hear that fractions are involved, C is going to be equal to negative 2/3 A minus 20/3, because I've got to distribute that division by 3 to both terms in that numerator. But the reason I wanted to solve C in terms of A and B in terms of A is because now I can substitute this B expression into this part of the equation, the second equation, this C expression into this part of the second equation, and they'll all be written in terms of A. So let me go ahead and start trying to write that out for us, right? So if I take this second equation, 12 equaling A plus 3B plus C, all right, I have 12 is going to equal A plus 3 times 8 minus A, all right, minus 2/3 A minus 20/3, right? Because I need to add C to it, all right? So let's take a look at what we're getting. I have 12 equaling A plus 24 minus 3A minus 2/3 A minus 20/3. Okay. Now, if you don't like the fractions, you could multiply everything by the LCD and knock them out. So let me do that just because if you actually look at the handwritten key for this problem, I didn't do it that way. So I just want to, again, show you alternate ways. So if I don't like the fractions, I can multiply everything by 3. So the left side and then all 3 terms on, no, not 3 terms, all 5 terms on the right side. So I can make this 36 equals 3A 24 times 3 is going to be 72. Negative 3a times 3 is going to be negative 9a. 2/3 a times 3, the 3's cancel by design, so this will be minus 2a. 3 times 20/3 minus 20. Right, so I got rid of the fractions. And if you prefer that, then by all means do it. Right, or maybe you just want to work this equation before I multiply by 3. You want to use your calculator for it. Again, totally your call. But if I look on the right side, I have a 3a, a negative 9a, and a negative 2a. So 3 minus 11 is essentially negative 8. And I'm just going to come over to the side here so I can do this. I have 36 equaling, this is going to be, we said negative 8a. And then 72 minus 20 is 52. All right. So what I want to do is I'm going to move the 8a over, right, to the left side. And then I'm going to subtract 36. And since I don't have my calculator on me, all right, 52 minus 36, I really am doing this a little long way. 6, and then this would be 16. I can do it. All right. So I'm going to get 16 on the right side. I'm going to divide both sides by 8. And I'm going to get a equaling 2. All right. So if I find out a is 2, great. Now I can go find b. So from here, I realize b is 8 minus 2, so b is 6. C is going to be a little bit funkier, so let's try this. If a is 2, this is going to be 2 times negative 2/3 is negative 4/3, minus 20/3. Luckily, those are already those are fractions with common denominators. Negative 4 minus 20 is negative 24/3. And negative 24 divided by 3 is ultimately going to be negative 8. So C is negative 8, right? So I have A is 2, B is 6, C is negative 8. So this is going to turn into 2 over x plus 3, and then 6x minus 8 over x squared plus x plus 2. And just looking at these two terms, they do have a 2 in common, so I could factor that out if I wanted to. So let me just kind of scooch this up, and let's talk about our end game answer, and then I want to show you an alternate way to get 6, negative 8, and 2 respectively. So we know 8x squared plus 12x minus 20, I'm going to put the little therefore, over x plus 3, x squared plus x plus 2 is going to be, okay, a over x plus 3 is going to be 2 over x plus 3. All right, bx plus c is going to be 6x minus 8 over x squared plus x plus 2. All right, and I just want to show you if you wanted to maybe take it one step further, which is not necessary, I could factor out that GCF of 2 up top. If I take out the 2, this is going to be 3x minus 4 x squared plus x plus 2. And if you had time and you wanted to check yourself, you could take this expression, right? You could take you could take this expression, get common denominators, add the numerators, and see if you got back to your original problem, okay? All right, so let me show you the alternate technique. And by alternate, I'm going to start at this level. I'm going to start with this equation. So I'm going to rewrite it just below what you can see. And then we're going to plug in x values. So I'm going to scooch this up. I'm going to put another separation bar just so we can see an alternate way to get negative 8, 6, and 2 respectively. All right, so let's say we have 8x squared plus 12x minus 20 equaling a x squared plus x plus 2, and then bx plus c times x plus 3. All right, so I want to find maybe a faster way, but just an alternate technique to finding a, b, and c respectively. And this is just the plug-in technique. So if I look at my factors on the right side, I can see an x plus 3. So strategically, it would be a good idea for me to plug in negative 3 because that would zero out this entire term. So I'm gonna start there. So I'm gonna let x equal negative 3. All right, when I do that, negative 3 squared is 9. 9 times 8 is 72. 12 times negative 3 is negative 36, and then I have another minus 20. Okay. I'm going to put the a here. All right, negative 3 squared is 9. 9 minus 3 is 6, and 6 plus 2 is 8. So I'm going to put the 8 there. All right. Negative 3 here, this factor will be negative 3b plus c, but it doesn't matter because this one zeroes out, right? So basically I have plus 0 over here. And when I simplify that a little bit, all right, 72 minus 36 minus 20. This is essentially 72 minus 56. All right, and that's going to leave me with 16 is going to be equal to 8a. And when I solve for a, I'm going to get a equaling 2, which that is consistent with what we got before, right? And I would argue it's probably a little faster than setting up the system of equations, but find the method that works best for you. And then you can pick in any other values of x. And what I tend to go for, I mean, I go strategically at first, right? This had an x plus 3, so I'm going to choose -3 because I know something's going to zero out. Then after that, I tend to choose x equaling 0, then 1, then -1, then 2, then -2. So since I haven't selected letting x equal 0 yet, let's let x equal 0. Things are nicer when x is 0 because that's 0, 0, -20. All right, 0, 0, 2, so this is going to be 2a, right? bx plus c, well, if x is 0, the only thing that survives in this factor is c. If x is 0, 0 plus 3 is 3. So I get this equation, but keep in mind you already knew a, so you can really start to substitute in. I've got -20. 2 times a is going to be 4 plus 3c. All right, well, if I subtract the 4 over, I'm looking at -24 equaling 3c. And when I divide by 3, I'm going to get c equaling -8. Right? That's consistent with what we had up top. Let me scooch this up just so I can finish this out for us. All right. So now what I'm going to do, I'm going to let x equal 1. And let's see what we get. All right, so 8 plus 12 is 20. Oh, this is nice. So then 20 minus 20, if I'm taking a look at it, is 0. All right, if x is 1, we have 1 plus 1 plus 2. So that's going to be 4a. All right, I'm going to do this. If x is 1, this factor becomes b plus c. And if x is 1, this factor becomes 4. So let me start to distribute and simplify this a little bit and figure out what b is equal to. So we have 0 equaling 4a. If I distribute the 4, this is going to be plus 4b plus 4c. Okay. So then let's start substituting in. 0 is going to equal, okay, 4 times a. Well, a is 2, so this is going to be 8. I don't know what b is. 4 times c, well, 4 times -8 is -32. Okay, so when I have 8 minus 32, that's going to be -24. All right, so 8 minus 32, -24, but when I move it to the other side, I'm going to get a positive 24. That's going to be equal to 4b. And when I divide both sides of that equation by 4, I'm going to get b equaling 6. Right? And I tend to think this is a faster method, the plug-in numbers versus the system of equations. But again, find the one that works best for you. Because there are some times when it might be faster to use systems of equations than plug-ins, but it's totally your choice. Okay, thanks. Bye.